Hello, guys. It's Jesse again. Just to show a simple usage of stacks for management of change histories and the like, and the implementation of undo and redo functions as it's relevant to us in the transcriber app, particularly for um, editing sections and then being able to revert and maybe go back to previous changes that were made or redo changes as it is. So we have a change stack. It's essentially a stack somewhat. We're using a list internally to represent the object that the stack holds. Um, and we can pick, we can check if it is empty and stuff. We can pop and stuff. And we're also having implementing the equality operator. So objects that hold references to it can determine when it changes effectively. So that requires us implementing the hash code operator too. Now, the change model actually holds the change history. It holds the undo stack, the redo stack, an array of changes. Although the array of changes appears to be a list, we see this identifiable here. Identifiable is it's just an abstraction I implemented that requires that the object has a UUID for identification purposes. It's relevant to the equality operator and the like. Now, for the change model, we will the reference to undo and redo histories and also the set of changes that we've made. We have a constructor that just implements empty items. It's an immutable class, right? And we only have an internal constructor and an internal copy with method. The commit change method, the internal method here, makes the changes array behave like a set. So if there's no change, we exit early. But if the change, we have an item in the change set that matches the ID of the new change, we remove that object in an if clause. Then we add the new version of the change here. In the make change, we commit the change early and we push the new change to the um, undo stack. Uh, then we return a new instance of the change model with the undo stack changes, but we reset the reduce stack. This is similar to when you have a Git repository and you make a change locally that changes the history of the repository on the remote source. When you try to push that, you see the unrelated history warning, and to avoid that and to minimize complication, we reset the reduce stack when a new change is made, and and that is what we are doing by returning just an empty change stack. Then on the undo change, we check if the undo stack is empty. If it's empty, there's no undo to do. We get the new change, we push the new change. That we pop the change in the undo stack, then we push that to the redo stack, and we commit the current latest version in the on the undo stack to the commit that change to the change set, and we return a version of the uh, change model that reflects that. We do something similar to that for the redo change. It's just an inversion of the um, logic for the undo stack method. And then we also have this equality operator. For example, when we're pushing this to a value notifier, if we don't implement this, perhaps you could use equitable, but I prefer using implementing my equality operators manually, especially when we have complicated objects like this. One reason why I'm spreading the changes here is because arrays are referential and not value types, and manual equalities or direct equality checks may not be representative of the true state of an array. And then we have a stringify method that just prints out the state of the object nicely. So I'm using this in this screen here, emitting it via a value notifier. This generic listener widget is just something I implemented. It wraps around, it's a wrap around value notifier. So let's get to use this on the screen. So yeah, I'm gonna load the detail screen for this transcription file, and let me just clear this so we see the update. I'm making the changes, and it's active now. So we have the redo and undo. There are no redo. There's no redo to make, so the redo button is um, grayed out. Um, so yeah, that's that. So once we redo, you see the current state of the change. Redo the history goes back. Now there's no undo to do anymore. I redo, we go back to a previous state. That's that there. That is the feature in use as it is.